In this video, we're going to find an alternative way of expressing a circle in parametric form. So we've seen it in this form, we've seen this, and we've seen this. By using this straight line here, we can come up with a new way of expressing a circle in parametric form. So this line here is being fixed right here, and t represents the steepness. T in our case represents the steepness of not the angle, but the steepness of this line. So for example, let me show you with an animation. So keep an eye on this orange dots here, and then t represents t represents the steepness of the line. So hang on. So if you look at the orange dot, it's always traveling along the circle. So if we can find a way of expressing that dot, then really we have a way of describing a circle. So hang on. So back to here. So t in our case represents the steepness of this line. So if you have a shallow gradient, if t is really small, then it has a shallow gradient. If we can find a way of expressing where this line intersects with a circle, then we will have a way of describing this circle in parametric form. So as you increase the steepness, not the angle but the steepness, if we can find a way of describing this dot here, or if t is really high, let's say this, well at the moment t is roughly 1, so it's going to be here. But then if t is really high, let's say you have a gradient of 99, so that's 1 across and then 99 up. So it's a really steep line, a really steep gradient. So hang on, it's a really steep gradient. So hang on, so really steep gradient. So the intersect would be somewhere around here. So as t heads towards infinity, then it's going to become near vertical, but there will be some sort of intersection near here. Okay, so to do this, we need a way of expressing this where the line intersects with this thing here. So start out with a straight line. So the straight line is y equals tx. This is an equation of a line going through the origin. It will have a gradient of t, so we can vary t. So if t is high, it will have this gradient. If t is low, it will look something like this. So this represents our line going through the origin, but we want our line to go through here. So if I give you this function, let's say you've got a function tx. If you want to move, so this is our line at the moment going through the origin. If you want to move this point to here, then you would apply this transformation. Plus 1, and then you would put this into here, so that would be t and then x plus 1. So the equation of our line would be given by this. Okay, so we are currently here, and then we would make use of this. So put this into here, and then square it. So when you square it, it becomes this. So when you square it, it becomes this. That will then take you to here. So we are trying to find we've got an equation for this straight line. Where the two intersect is what we're interested in. We're interested in where the two will intersect. So that's why we are putting this into here and find where the two will intersect. Okay. I will continue in the next video. Okay.